Okay, then third one, stereochemistry of diene plus dienophile. Stereochemistry of diene plus dienophile. This is the way of approaching this question. First we discussed the stereochemistry of dienophile, then diene plus dienophile. Okay, consider an example. Example 1. A simple diene, this is 1,3-butadiene. Here two substituents are there. Plus, here two substituents are there. Then, this is CHO. Two substituents are on the same side. Okay. Here you know with respect to diene, the two substituents are opposite. One upside, other downside. Opposite means these two methyl groups are cis. No doubt. Very complicated. I will try my best. Okay. So here two substituents are on opposite side. With respect to this diene. Then opposite means OC. Stereochemistry of these two methyl group will be cis. Okay. Here dienophile, same 2CHO on same side of the dienophile. So dienophile is cis. So the product also cis. With respect to dienophile, the product will also be cis. Okay. Then how you can write the product under thermal condition? Okay. Then a simple 4+2 cycloaddition reaction. 1, 2, 3, 4, 5, 6. A 6-membered ring will be your product. Between these two carbons, a pi bond is there. Okay. Then you have to represent the stereochemistry of these two methyl groups and these two CHO. You know, cis dienophile will give a cis product. That means 2 CHO on same plane. 2 CHO groups on same plane. This is the first CHO and this is the second CHO. Both are on same plane. Okay. So these two are on same plane means cis. Okay. Here also two substituents opposite side. That means they are also cis. That means two methyl groups are on same plane. These two methyl groups are also cis. So that is the product. One more possibility is there. Plus another possibility. A 6-membered ring. Here a double bond. These two CHO groups are cis. Okay. CHO and CHO on same plane. Then these two methyl groups are on same plane. Okay. These two methyl groups are on same plane. Okay. So here cis product with respect to this one also cis. My question, both possibilities are there. Okay. 2 CHO cis. 2 methyl groups cis. Here also 2 methyl group on same plane. This is product number 1 and this is product number 2. My question, which product is the major product? This is a stereoselective reaction, not a specific reaction. Stereoselective reaction. Possibility of more than one product, that is a selective reaction. And then one product will be the major product. Then my question, which product will be the major product? First one or second one? This product can also be written in another form. Sometimes in question paper, this product will be given in this fashion. For example, 2 methyl groups on same plane, both CHO in same plane. These two are identical. Both these structures are identical. Okay, both these structures are identical. Clear? Above or below depends on the observer. When I am looking at a molecule, sometimes the one group will be towards me, towards the observer. At the same time, that will be away from the observer with respect to you. That's a relative. So these two structures are identical. No, so not considering this one. Not considering this one. My question, whether the product 1 or 2 is the major product. Product 1 or 2 is the major product. That's my question. This product 1 is the major product. This product 1 will be the major product. Okay, product 1 will be the major product. How you can explain this? How you can explain this? The explanation is very complicated. I think you studied about the explanation in the PG classes. But I will give you some tips or some short tricks to identify the stereochemistry. This product 1 will be the major product. I will explain. Give the. We can study the explanation. 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 Please listen. Okay, explanation. This is your question. A diene. Here a CH3 groups. Here a CH3 group. Here a CH3 group. Both are on opposite side. Double bond CHO, CHO under thermal condition. Okay, that's the reaction. Then a 6-membered ring is formed. 6-membered ring is formed. Here a pi bond. Then stereochemistry. These two are cis. These two are on same plane. These two are on same plane. Okay. These two are also cis. These two are also cis. Solid wedge or dash wedge both are equivalent. Solid wedge or dash wedge both are equivalent. Okay. So this is the major product. Solid line or dash line, that is relative, that depends on. So these two, this is the major product. How you can explain this is the major product? In this type of questions, how you can predict the stereochemistry? So a short trick. Explanation is very complicated. That you studied in the MSc classes. No need to study that explanation in CSIR, net or gate point of view. I am giving you a short trick. Okay. Consider the diene. This is your diene. This is your diene. No doubt. Plus the dienophile containing electron withdrawing group. Dienophile containing electron withdrawing group. The electron withdrawing group must be close to the diene. The electron withdrawing group must be close to the diene, because when the electron withdrawing group will be close to the diene, secondary interactions will be favorable. Secondary interaction will be favorable. That is very favorable for the formation of the cyclic product. So the electron withdrawing group must be close to the diene. Okay, so you can draw the reactant, two reactant in this fashion. Remember, the electron withdrawing group must be close to the diene because for the reason of secondary interactions. Okay, secondary interactions. Then you have two. This is carbon number 1. This is carbon number 4. Carbon number 1 and the carbon number 4. Then draw a line from carbon 1 to carbon 4. Draw a line from carbon 1 to carbon 4. Okay. Those substituents on the line. Those substituents on the line and on the left side of the line, and on the left side of the line are below the plane. This is the first tip that I am giving to you. Okay, you have to draw a line from carbon 1 to 4. carbon 1 to 4. Those substituents which are present on the line or on the left side of the line are below the plane. Are below the plane. Okay. Then those substituents are on the right side. Substituents on the right side of the line. Right side of the line are above the plane. This is the second tip. Most important. Those substituents are on the left side of the line, on the line or left side of the line are below the plane, on the right side of the line are above the plane. Okay, here these two substituents are on the line, so below the plane. Then here also draw a line between 1 and 2. Those substituents are on the line and the left side of the line are below the plane. If substituent is at the right side, that is above the plane. So here 1, 2, 3, 4. 4 substituents are below the plane. So what is the product? These two substituents are below the plane. CHO. Below the plane, CHO. These two methyl groups are also below the plane. Below the plane. This below the plane can also be represented by using solid wedge also. So all 4 substituents having the same stereochemistry. So this will be your major product. So how we can predict the major product? Take the diene and draw a line from carbon 1 to 4. Those substituents present on the line or on the left side of the line are below the plane. Those substituents on the right side of the line are above the plane. Similarly, draw a line between carbon 1 and 2 of the dienophile. Those substituents on the left side of the dienophile are below the plane. LB, left side below the plane. LB. On the right side of the line are above the plane. So that's the stereochemistry. Okay, that's the stereochemistry. So this will be your major product. Okay, then one more example. Write another example. Example 2. Here a diene is there. This is 1,3-butadiene. Here one substituent. Here another substituent. Plus double bond CHO. Under thermal condition. You have to predict the stereochemistry. Of these two methyl groups and this CHO group. Before that, write the product. Product that you know, it is a simple 1,4 4+2 cycloaddition reaction, so that a 6-membered ring is formed. Here a double bond. Okay. Then what is the stereochemistry of these two methyl groups and this CHO? For that, you can follow this trick. Draw the diene. This is the diene. Here a substituent is present. Plus, if the dienophile contains an electron withdrawing group, that will be close to the diene. Then only secondary interactions will be favorable. Okay. Then draw a line from carbon 1 to 4. Okay, here also carbon 1 and 2. Draw a line from carbon 1 and 2. Those substituents on the line are below the plane. On the left side of the line are also below the plane. On the right side of the line are above the plane. Those substituents on the right side of the line are above the plane. So you can sketch the stereochemistry. This methyl is below the plane. This methyl group is below the plane. This methyl group is above the plane. This methyl group is above the plane. Then this CHO group is below the plane. Okay, this is the arrangement. This is the arrangement. This sometimes in your question paper, this will also be given in this fashion. Both are identical. Both are identical. For example, they may represent below the plane by using solid wedge and above the plane by using dash wedge. Below the plane you are using solid wedge. Okay, these two are identical. These two are identical. That you have to memorize. But we can follow one notation. So this will be the stereochemistry of your product. Stereochemistry of your product. Below the plane, above the plane, and below the plane. Okay, then third question. Third question, a diene is given. This is a diene. One substituent below, other substituent above. Okay. Plus a dienophile. A dienophile. This is one CHO. This is other CHO. They are trans. Under thermal condition. Under thermal condition. How we can write the product? Product that you can write a symbol 4+2 cyclo addition reaction. A symbol 4+2 cyclo addition reaction. So a 6-membered ring is formed between these two carbons. A pi bond is there. Okay, you have to predict the stereochemistry of these two methyl groups and these two CHO. Okay, for that you can follow the easy method. Sketch the diene. One substituent here, other substituent here. Plus the electron withdrawing group must be close to the diene, but here this is trans. So only one withdrawing group will be close to the diene. Other CHO is trans to that. Okay, then this is carbon number 1 and 4. Draw a line between carbon number 1 and 4. Similarly, here draw a line from carbon 1 to 2. Those substituents on the line and the left side. On the line and the left side are below the plane. This is left side of the line. So below the plane. Those substituents on the right side of the line are above the plane. So this is above. This is above. This is also above. This is also above. Then sketch the stereochemistry. This first methyl group is above the plane. Above the plane can be represented by solid wedge or dash wedge. That depends on the option in your question paper. This is also above the plane. This is also above the plane. Then this CHO is also above the plane. This is below the plane. This is CHO. Then this CHO is below the plane. That means this group and this group having same stereochemistry. Represented by solid wedge or dash wedge. This CH3 and this CHO having are on same plane. This is in another plane. That is the net meaning. This CH3 and this CH3 in one plane and this CHO in the opposite plane. Okay, that's your product. So this is the method of writing the product. Okay, that is question number 3. Then question number 4. Question number 4. A simple diene, 1,3-butadiene. Here a substituent below, here a substituent above, plus a dienophile which is having CHO and NO2. CHO and NO2 under thermal condition. Okay. What is the product? Product that you can represent the product, a symbol 4+2 cyclo addition reaction. So that 1, 2, 3, 4, 5, 6. A 6-membered ring is formed. Between these two carbon, a pi bond is there. Okay. Then you have to represent the stereochemistry of these two methyl groups and CHO and NO2. How you can represent the stereochemistry? Okay. For that, sketch the diene. This is the arrangement of two methyl groups. Then electron withdrawing group of the dienophile will be more close to the diene. Electron withdrawing group. Here two electron withdrawing groups are there. NO2 and CHO. But NO2 is the powerful withdrawing group. NO2 is the powerful electron withdrawing group. The strength of electron withdrawing group that we will study in the GOC section, General Organic Chemistry section. Okay. So NO2 is a powerful electron withdrawing group. Powerful electron withdrawing group. So NO2 will be more close to the diene. Then only secondary interaction will be favorable. So this is the dienophile. NO2 must be close to the diene. CHO is trans to that. CHO is trans to that. Then draw a line between carbon number 1 and 4. Okay. Here also draw a line between carbon number 1 and 2. Okay. Those substituents on the line and the left side are below the plane. Those are on the right side are above the plane. Above the plane. Then represent the stereochemistry. First methyl group above the plane. Above the plane can be represented in this fashion also. Second methyl group is also above the plane. Solid or dash beds, that is stereochemistry is relative. In order to avoid the confusion, we can follow one notation. Okay, we can follow one notation. First CH3 is above the plane. Second CH3 is also above the plane. Okay. Then this CHO is above the plane. This NO2 in this carbon is below the plane. The meaning is these two methyl groups and the CHO are on same plane. NO2 in the opposite plane. So that is the stereochemistry. Of this question. Okay. Stereochemistry of Diels-Alder reaction is very, very, very important. Then another question. Question number 5. Question number 5. A simple diene. Okay, one methyl group here, other substituent, plus double bond NO2 CHO under thermal condition. Okay, under thermal condition, what will be the product? Product is a simple 4+2 cycloaddition reaction. A 6-membered ring will be your product. Between these two carbons, a pi bond is there. You have to represent the stereochemistry of these two methyl groups and this NO2 and the CHO. For that, you can follow the simple method. Sketch the diene. Here a substituent, here another substituent. Plus, here two electron withdrawing groups are there, but NO2 is powerful electron withdrawing group. Powerful EWG. So that will be more close to the diene. Then only secondary interaction will be maximum. So most powerful withdrawing group will be more close to the diene. So NO2 is more close to the diene. CHO is trans to that. Then you can predict the stereochemistry between carbon number 1 and 4. Draw a line. Between carbon 1 and 2, draw a line. Okay. Then those substituents on the line below and on the left side below. Those on the right side above. Okay. So this is above. This is below. Above. Then mark the stereochemistry. First methyl group above the plane. Second methyl group below the plane. This NO2 is below the plane. Okay. CHO is above the plane. Meaning is one methyl and CHO having same stereochemistry, NO2 and other methyl group having same stereochemistry. That is the meaning. So that is the product. Okay, question number 6. A diene. Okay, here an OCH3 group and here a CH3 group. OCH3 group and a CH3 group plus a dienophile. This is CH3 and this is CHO under thermal condition. Okay, so please listen. Here not only you have to think about stereochemistry, stereoselectivity as well as regioselectivity. Why? Because your diene is unsymmetrical, dienophile is also unsymmetrical. If both diene and dienophile are unsymmetrical, you have to think about regioselectivity as well as stereoselectivity. So how you can approach this question? Here both substituents are electron donating group. This is plus mesomeric effect because oxygen containing lone pair. This is hyperconjugation, plus H, hyperconjugation. Okay, so comparing OCH3 and CH3, OCH3 is a better donating group. Its electron density will be concentrated in the fourth carbon. Its electron density, so fourth carbon having delta minus. Okay, so CH3 is electron donating, CHO is electron withdrawing. So this is electron withdrawing group. So this position having positive charge. So interaction is between these two carbons. So you can represent the reaction in this fashion. This is the diene having OCH3 and CH3. Okay, here the delta minus charge, reaction is built, there is electrostatic interaction between negative and positive charge. So reverse the dienophile. On reversing the dienophile, this is CHO and this is CH3. Both are trans. With respect to CHO, here positive charge is there. So negative and positive will interact. There is electrostatic interaction. Then you can write the product. Product will be a simple 4+2 cycloaddition reaction. 4+2 cycloaddition Diels-Alder reaction. So that a 6-membered ring will be your product. Between these two carbons a pi bond is formed. Then you have to think about the stereochemistry of. So regioselectivity that we discussed. Then think about the stereochemistry. For that, take the diene. This is diene. And diene containing here an OCH3 group and here a CH3 group. Plus dienophile. Electron withdrawing group will be close to the dienophile. So CHO is close to the dienophile. Opposite to that a CH3 is there. Everything same. Then draw a line between carbon number 1 and 4. Draw a line between carbon number 1 and 4. Here carbon 1 and 2. Those substituents on the line. This OCH3 is on the line. That will be below the plane. This CH3 is on the line. That will be below the plane. This is left side of the line. Below the plane. This is right side of the line. Above the plane. Then mark the stereochemistry. First OCH3 is below the plane. OCH3 is below the plane. Next CH3 is also below the plane. CH3 is also below the plane. Then this CHO is below the plane. This CHO is below the plane. This CH3. The CH3 is above the plane. CH3 is above the plane. Same product. OCH3, CHO, CH3, CH3. Stereochemistry. So here you have to consider the regioselectivity as well as stereoselectivity, because both the diene and dienophile are unsymmetrical. You have to think about regioselectivity also. Okay. Then question number 7 and the last question. Okay. A diene is there, double bond, NH CH2 pH. NHCH2 pH is called NHBN. Plus a dienophile is there, CHO. This is the dienophile. First condition, thermal condition. Second condition, H2 bar PDC. Second condition, H2 bar PDC. Okay. So simply a 4+2 cycloaddition reaction. So here electron shifting will take place. So that a 6-membered ring will be your product. Between these two carbons, a pi bond is there. So you have to find the stereochemistry. Okay. Here between these two carbon, a pi bond is there. So what will be the stereochemistry of the groups? So that take the diene. This is the diene, and here this diene containing a group NHCH2PH. Then your dienophile containing an electron withdrawing group. Electron withdrawing group must be close to the diene. For that, electrostatic interaction will be higher. So both electron withdrawing group are close to the diene. Then this is carbon number 1 and carbon number 4. Then draw a line from carbon number 1 to 4. Here also between carbon 1 and 2, draw a line. Those substituents on the line below the plane. On the left side of the line, below the plane. So all substituents are below the plane. So this is NH CH2 PH. Okay. So here a CHO is there. So that CHO is also below the plane. So that is the product formed. Then in the next step, H2 bar PDC. H2 bar PDC. What will be the product? H2 bar PDC. What will be the product? Okay. Hydrogenation, reduction of double bond as well as RNHBN. I already told you that RNHBN. BN is the CH2 PH group is called BN. On reduction using H2 bar PDC, this is converted to RNH2. So what will be the final product with the stereochemistry? Double bond is reduced. So here below the plane NH2, here below the plane CHO, here below the plane CHO. So that will be your final product. So that's all about the stereochemistry of diene plus dienophile. And the last one, fourth one, stereochemistry of cyclic dienes. When your diene is a cyclic diene, what will be the stereochemistry? That is the next question. So consider an example. A cyclic diene is there. On reaction with a dienophile CHO under thermal condition is thermal. What will be the product? A simple 4+2 cycloaddition reaction. Okay, so giving number, this is carbon 1, 2, 3, 4, 5, 6. A 6-membered ring with a bridged carbon. So a Norbornyle system will be formed. This is a 6-membered ring with a bridged carbon at 1 and 4. This is carbon 1, this is 4, this is carbon 1, 4. At 1 and 4 a bridged carbon is there. Between these two carbons a pi bond is formed. Then my question, what will be the stereochemistry of this CHO? In the case of Norbornine system, cis and trans is not mentioned, above the plane or below the plane. In Norbornine system, whether the substituents on endo or exo, that is the question. Substituents are on endo side or exo side. Okay, substituents are on endo or exo. What will be endo? What will be exo? Consider a Norbornine system. This is a Norbornine system. Okay. with a bridge. Those substituents below, this position is called endo, this position is called endo. Those substituents above, this is called exo, this is called exo. Here also those substituents below is called endo. Those substituents above is called exo. So in Norbornine system, four corners, first corner, second corner, third corner, fourth corner. Below is called endo, above is called exo. Above is called exo. For example, consider this as a Norbornine system, like this, a curved surface. Okay, those substituents below to the curve, below is called endo, above is called exo. Clear? This is a Norbornine system. Those substituents below is called endo, above to that is called as exo. Okay, so that is the Norbornine system. Endo position, exo position. Then my question, whether the CHO is in endo position or exo position. This is the hint. Electron withdrawing group will always in endo position. Electron withdrawing group will always be in endo position because secondary interaction will be favorable. Because secondary interaction will be favorable. Secondary interaction will be favorable. Okay, electron withdrawing group will always be in endo position. So here at this carbon, this is carbon number 1, 2, 3, 4. This is carbon number 1, 2, 3, 4. This is carbon number 5, 6. This is carbon number 5, 6. At the carbon number 5, there is a CHO group. CHO is an electron withdrawing group. Electron withdrawing group always be in endo position. Endo is the downward position. So CHO will be in endo position. At the same time, a hydrogen is also present in that carbon. That hydrogen is in exo position. That hydrogen is in exo position. So CHO in endo position, the hydrogen is in exo position. So that is the stereochemistry of cyclic diene. In the case of cyclic diene, the product will be a Norbornine system. In the case of cyclic diene, the product will be a Norbornine system. In such cases, the electron withdrawing group will always be in endo position. Endo is the downward position of that curved cyclic product. Okay, then second question. A cyclic diene, this is a cyclic diene plus a dienophile under thermal condition. What will be the product? This is the product. A 6-membered ring with a bridged carbon. That the product is a Norbornine system. Okay, between these two carbons, a pi bond is there. What is the stereochemistry of these two CHO groups? In the case of Norbornine system, stereochemistry is endo or exo, not cis-o above the plane or below the plane. This is endo or exo. Below the plane, below exo, above, below endo, above exo. Okay, so CHO is an electron withdrawing group. Electron withdrawing group always be in endo position. So CHO in endo position. Here also CHO in endo position. Therefore, the corresponding hydrogen will be in exo position. CHO in endo position and hydrogen will be in exo position. Clear? Okay, then third question. Third question. A cyclic diene plus dienophile containing NO2 and CHO. NO2 and CHO are trans to each other. NO2 and CHO are trans to each other. Under thermal condition. Under thermal condition. Regioselectivity is not there because this is symmetrical. 4 plus 2 cycloaddition reaction. A 6-membered ring with a bridged carbon. A 6-membered ring with a bridged carbon. This will be your product. Between these two carbons a pi bond is there. Then what is the stereochemistry? Both are trans to each other. If both are trans to each other, both are electron withdrawing, but both will not be in endo position because both are trans to each other. Clear? Both are electron withdrawing group. So both in endo position is not possible. The most powerful withdrawing in endo position. The most powerful withdrawing is NO2. So NO2 will be in endo position. Okay. If two withdrawing groups are trans to each other, the more powerful withdrawing group will be in endo position. So this NO2 will be in endo position. NO2 will be in endo position. Corresponding hydrogen is in exo position. Okay. Here CHO is in exo position. CHO is in exo position and the corresponding hydrogen is in endo position. Okay, corresponding hydrogen is in endo position. So that will be the product. That will be the product. Okay, question number 4. Question number 4. Question number 4. A cyclic diene. A cyclic diene is there. This is a cyclic diene plus dienophile CHO which is a dienophile under thermal condition. Under thermal condition, what will be the product? Product will be a 6-membered ring with a bridged carbon. So a 6-membered ring will be formed and a bridged carbon will be there. Between these two carbon atoms a pi bond is there. Then what is the stereochemistry of these two? Both are cis and also withdrawing groups. So they will be in endo position. Withdrawing group in endo position. Withdrawing group in endo position. So the corresponding hydrogen will be in exo position. Corresponding hydrogen will be in exo position. Okay. Then the last question. 5th question. 5th question. A diene is there. This is a diene. This was one of the previous question. A diene plus a dienophile double bond O, malic anhydride under thermal condition. What will be the product? A diene and a dienophile under thermal condition. What will be the product? 4 plus 2 cycloaddition reaction. Here 1, 2, 3, 4, 5, 6. A 6-membered ring with a bridged carbon. A Norbornene system will be your product. A 6-membered ring with a bridged carbon. Okay. Then here hydrogen is present. At this carbon hydrogen is present. But hydrogen is not an electron withdrawing group. Hydrogen is not an electron withdrawing group, but this C double bond O is an electron withdrawing group. This C double bond O. So this portion is an electron withdrawing group. Electron withdrawing group will be in endo position. Electron withdrawing group will be in endo position. That is the electron withdrawing group C double bond O. Here also C double bond O. So that electron withdrawing group in endo position and the corresponding hydrogens in exo position. That will be your product. Clear? That here a pi bond is there, double bond is there. So that is the product. Why that the remaining portion of the dienophile, that is malic anhydride, C double bond O, that is in endo position. Hydrogens are in exo position. That will be the stereochemistry. Very, very important. And this was one of the previous question. Why this C double bond O is in endo position? Because that is the withdrawing group there. The more powerful electron withdrawing group will always be in endo position and other hydrogen will be in exo position. In the case of Norbornene system, this cyclic 6-membered ring with a bridged, that is a Norbornene system. Above or below plane is not used. Instead of exo or endo stereochemistry is used. So that's all about the stereochemistry of Diels-Alder reaction. Stereochemistry with respect to dienophile, with respect to diene, diene plus dienophile and the cyclic diene. Then in the next lecture we will discuss a few aspects of intramolecular Diels-Alder reaction. Then Diels-Alder reaction will be completed. Then we will go to chelotropic reaction.